Unit 3 Chemistry, Chapter 5, Part 1. So this area of study is all about energy and heat transfer, and we've been talking about redox reactions. Well, the reason we've been talking about redox reactions is because we can use them to harness the energy in a reaction. Rather than harnessing it as heat energy, we can harness it as electrical energy. And one of the ways we can do that is using a galvanic cell. So when we talk about a cell or a battery, what we're normally talking about when we colloquially say a battery is actually a cell. It's a chemical reaction that produces electrical energy. Okay? Most of the batteries that you would put into devices or you'd have in your phone are essentially small portable galvanic cells. Okay? A cell is one galvanic cell. If we talk about a battery in scientific terms, we are talking about a number of cells linked together. There are a few different types that you're going to study over the course of this unit. Primary cells, which are non-rechargeable, secondary cells, which are rechargeable, and fuel cells, which burn fuels, essentially. So, hopefully you touched on this in Year 11, galvanic cells, where we can separate a redox reaction into two separate vessels. The oxidation reaction occurs in one container and the reduction in the other. And you have a salt bridge to make sure that the ions can be moved, which completes the circuit and also balances the charge in each beaker. We've then got our external circuit, which allows the movement of electrons. Okay, and that movement of electrons is an electrical current. So this would be our galvanic cell. Here we've got one half cell, which is our copper half cell. We've got a piece of copper as our electrode, and we are having, in this instance, copper is being reduced. So we've got copper ions in there. Okay. The other half cell here is zinc. So we've got a piece of zinc acting as the anode, and we've got zinc solution as well. We always have both the oxidant and the reductant in the half cells. Okay. Here is our external circuit, where we are having movement of electrons. And then we complete the circuit through the movement of charged ions. So here, some going up there, some going down there, okay, throughout the whole way. Because remember, for electrical circuit to flow, we need a complete circuit, but it doesn't have to always be electrons that are moving. It has to be a charged particle. Ions are just fine. Okay? Now, this was the first commercially useful galvanic cell. It's called the DANIELL cell because it was made by Daniell. It was used to power what was called the telegraph network in Britain. People used to send telegrams way back when, before phones were really in use. We're talking back in the sort of early 19th century, but it was very useful. Okay? Because it's consistent. It produces not particularly high power, but it keeps on doing it until either one of your electrodes wears away or one of your solutions really runs out of ions, both of which can be easily replenished. So it's a very reliable source of power. Okay. So those two beakers, or in the case of a more commercial cell, the two sort of cells, are made up of two half cells, oxidation and reduction reactions, which are physically separating from each other. Okay. Each half cell has the oxidation and reduction conjugate pair. And each half cell will also have an electrode, which is normally a piece of metal, and it's normally the metal which is part of your oxidation reduction half pair, but it could be something else, like a bit of graphite, which is going to conduct electricity. Okay? They would allow the flow of electrons, which is our electrical circuit. And we'd also have something which allows the movement of ions, yeah, which completes our circuit. Without connecting them, those two beakers will just sit there and not react. If we mix them together, they'd react, but they'd give out energy in the form of heat rather than electricity. So, the electrodes in them, wherever oxidation occurs, we say that has a negative charge because electrons are released there, and electrons are negatively charged, so we say they are. It's called the anode. Okay, a negative electrode. That's how I like to think of it. The electrode where reduction occurs is assigned a positive charge because electrons go towards it, and being negatively charged, they're going to be attracted to something positive, and we call it the cathode. The way I like to remember it is that cats make me feel happy, so the cathode is positive. If you don't like cats, that probably won't work for you. The most typical electrodes are metals, but it could be an unreactive metal like platinum if you've got ions and gases in there, or it could be graphite, which will conduct electricity without reacting.